Question 47. What is the least integer value of k such that this equation has no real roots? So for a quadratic equation to have no real roots, its determinant, I mean not determinant, its discriminant must be smaller than 0. So let's the discriminants. So let me write down the formula for the discriminant. So if we have a quadratic equation, a square of x plus bx plus c is 0, then the discriminant delta would be equal to square b minus 4 times a and c. So this is a formula for discriminant, and we can actually find the root to the equation. X1 will be equal to minus b plus the square root of the determinant over 2 times a, and x2 is the second root of the quadratic equation, will be equal to minus b um, minus b um, minus minus square root of delta over 2a. Okay, so this is a formula for any quadratic equation. But notice that this this x1 and x2 is only defined when delta is larger or equal to 0, because if delta is smaller than 0, we can't take the square root of it, or else it could be an imaginary number uh, which is not a real number. So we can't take so if an equation, if a quadratic equation have a negative delta, it will no longer have real roots, right? So if it has the delta is if the delta is equal to 0, especially if it's larger than 0, then x1 will be different from x2, right? But if delta is equal to 0, x1 will be equal. So this means that we have two real roots. So x1 is different from x2, and if delta is 0, x1 will be equal to x2, and this will only have one double root. So this quadratic equation will only have one double root. But if delta is smaller than 0, then we have no root, because both of this will be undefined, because both of the roots will have the square root on in the equation. So we need to find the value of delta smaller than 0, so that it has no real roots. So we need to find the value of k by let me erase this. So we need to find the value of k so that our delta in the quadratic equation of the question will be negative. So okay, oh, sorry. Okay, so our delta in the equation is square b. Square b is minus 6 squared minus 4 times a is 3k plus 1. A is the first coefficient, times the last coefficient. Last coefficient is 2. Okay, and this is 36 minus 8 of 3k plus 1, and we can figure out this is 36, 24 here, multiply each of this in the bracket, and this is 24k. And notice there's a minus sign here, so we must change the sign inside the bracket. So this is minus 8, and this must be smaller than 0. This thing here must be smaller than 0. So 36 minus 8 is 28, right? 28. 38 must subtract by 24k must be smaller than 0. Okay, and we can change this to the right side, and we find that k um, is like this, and therefore we can figure out k must be larger than 28 over 24. Right, so this is our so k must be larger than this number in order, this fraction, in order to satisfy the condition that it has no zero roots. So what is so it's the question asks is not this fraction. It asks for uh, the least integer value of k which satisfy this expression. So let me just divide that. So it is approximately 1.166. Okay, so k, if k is an integer, k must be larger or equal to 2, right? So 2 must be the minimum number for which this equation has no real roots. So the answer is B for question 47.